All right, let's get started. Good afternoon, everybody. Welcome to Chem 170 with your host, me, Dr. White. Hi. All right, couple quick things. First of all, I have it set up so your microphone is shut off on mute. Otherwise, if everybody had it on, all the background noise would not be conducive to you learning organic chemistry. However, if you have a question, feel free to turn your mic on and ask a question or use the chat. Now, I'll be honest, I've been using Zoom now for over, 2 years teaching this class. And once in a while, I forget to look down at the bottom of my screen, see if somebody has a question from chat. But usually I'll pick it up. I'm not ignoring you. All right, a couple important things. First of all, this semester, you'll learn a lot about me personally. It slips out during my lectures. And first of all, I'm an organic chemist. I've been teaching at ECC for a long time, but for many decades, yeah, I am that old. I had to say, oh, yep, I am. But anyways, I was a senior research and development manager for a couple of different international chemical companies. And I was located here in the Chicagoland area. I'm from the Chicagoland area. So I'm quite biased about organic chemistry, but unlike other instructors, I've worked with organic chemistry in the real world, really. And you'll find out about that during the semester. And that's what makes organic chemistry fun, using it in the real world. Not just, oh, okay, here's an academic thing. No, use it in the real world. All right, a couple other things. One, if we were face to face right now, I'd be telling you, I've got my bionic ears in, which you can see I don't, my hearing aids. It's hereditary. I'm lucky. I only have about a 50% hearing loss. My older sister has about a 65, 70%. But anyways, right above my monitor and my desk here on a shelf, I have two large speakers that are amplified, which is why I don't need my hearing aids now. But what that does mean is if you talk with an accent, or if you talk softly, or if you talk softly with an accent, I might have trouble understanding you. That's my problem. Bear with me if I ask you to repeat something once or twice. All right, next thing. And this is probably one of the most important things I'll teach you today. In my universe, there's no such thing as a dumb question. I'll say it again. In my universe, there's no such thing as a dumb question. If you got a question, ask. Do I know the answers to everything? No. Do I know about organic chemistry? Yes, quite well. But ask. It took until I think it was my second year, end of my second year in grad school. I went to Michigan State. That's where I got my PhD in synthetic organic chemistry. By the way, synthetic is a fancy word meaning to make. And that's my training is to make molecules, organic molecules. But anyways, we had a postdoctoral fellow. I still remember Dr. Plavin, and I'll always be forever grateful to Dr. Plavin. He was with our research group, a postdoctoral fellow, is a PhD who hasn't got a full-time job yet. And you go work for another professor at another school doing research, and you get paid, and it gives you time to find a job while you're making money. That's good on your resume. I was a postdoctoral fellow at University of Illinois, Chicago Circle, or campus, whatever they call it these days. But anyways, and I was giving a talk about my research to our research group, and Dr. Plavin asked me, what's this? And it's called the mechanism of a reaction, which I explained to him. And afterward, I went up to him and said, and his first name was Larry. Larry, weren't you embarrassed asking that question? We teach that mechanism to first-year organic students who take a 2-semester organic. Relax, we're not doing mechanisms in this class. You can all go like that now. By the way, I have a sense of humor and I use it. But anyways, he said, why should I be embarrassed? I didn't know the answer. Now I do. Why should you ever be embarrassed asking questions? At that point, I realized, you shouldn't be embarrassed. And I came up with the way I say it, there's no such thing as a dumb question. So always feel free to ask questions, whether it's here or my office hours. All right, one thing I'll be doing, and I'm going to do it right now, is keep on always. All right, everybody see the white screen? There's I don't know if you call it a bug, but a problem with Zoom. And sometimes when I'll be showing you stuff, Zoom tells me you're seeing it and you're not. So I've come up with what I call my thumbs up people. And for those of you who have, or those of you who don't, if you see the white screen, give me a thumbs up. All right, thank you. Now, one of the things I perfected on Zoom a long time ago was I can do the same thing on Zoom like I do in a whiteboard in a class. And what I'm going to do, and do not write this down. Trust me, I'm a chemist. Did that work? But anyways, this is propane. And propane has 3 carbons and all these hydrogens, CH3, CH2, CH3. That's propane. By the way, the next 40 minutes or so, I'm going to try and go for the Guinness World's Record for saying propane and writing it the most times in about a 35, 40-minute period. And you'll find out later why. All right. Important thing I have to ask right now, and I'm going to go to gallery view so I can see. If you cannot read cursive, give me a thumbs up right now. I'm learning okay. I see one, that's all I have to. I'll print, but I have the reviews I have on D2L, I'll have to redo because they're all in cursive. By the way, generation gap, things happen in my class at times. If you notice, I'm a little older generation gap. How old? Oh, should I do this? Yeah. How many of you remember what you were doing back in 2001? That's when I got my last US patent. Anyways, I shouldn't have asked that. Next, you're going to say my hair is graying and I'm feeling old. No, not really. All right, let's get to work. Remember, there's no such thing as a dumb question. And by the way, if I ever write in cursive, sometimes I just forget, because that's how I got brought up, writing in cursive. I also learned printing, but by 2nd grade, we were expected to do cursive, not printing. But anyways, tell me you're writing using cursive, not printing. All right. Once again, propane, it's CH3, CH2, CH3, propane. And if you haven't figured out, propane is the organic molecule that you buy in those white tanks that you use for your barbecue and other things it can be used for. All right, not this week, but next week, starting next Monday, I'll also be teaching the similar course at College of DuPage. Now there I'll be doing it face-to-face. The reason I'm telling you this is the fact that on Tuesdays and Thursdays, I end up finishing at 12:50, almost 1 o'clock. It takes me about 35, 40 minutes to get home. And then I'm going to be teaching here at 2 o'clock. What that means is that the weather's bad, traffic's bad, or whatever could happen to slow me down. I might be 5 or 10 minutes late. If I'm running late, you can log on to Zoom. Please be patient. Just be wait. Hopefully that won't happen. I've got it timed, so it should be okay, but life happens, as they say. By the way, I'm looking over here at my notes for today's lecture. All right. Now I've seen, and do not raise your hand or any thumbs up or anything from the roster that the school has for me to look at. A number of you have put down that you are repeating organic chemistry. And I'm going to assume you've taken it at another school, not with me, because if you're with me, rarely do people repeat, like almost rarely. I think in the last, I've been teaching 170 here since 2008. Wow. Anyways, I think I've only had about 5 or 6, not even that many, 3 or 4 who had to repeat or repeat it. All right. If you are, relax. Students do good in my class, and especially those who repeat, if you follow my advice on how to do good in the class, and I'll be teaching you that today. All right. Meanwhile, it's time once again for propane. Let's go to another color ink so I can do that. Thumbs up, people. Do you see propane on your screen? Thank you. And propane is CH3, CH2, CH3. Don't write this down. All right. Now, if you're here or if you're not, and I know a couple of you have registered today and haven't gotten clearance, but you will, you'll have access to, it's called Desire to Learn. That's the college computer system. It goes by the acronym that I'll use, D2L. Now at COD, they use a system called Blackboard. If I say you can find it on Blackboard, I just mixed up the schools. Don't give me that, well, you can give me that strange look. By the way, I'm looking at the monitor, not my camera, so I'll never be a TV announcer. Not that I want to, but anyways, let's go to D2L. And does everybody see thumbs up, people, D2L organic on your screen? Thank you. All right, now I've got some stuff here. Let's look at the left side. I have here for the times when we meet, and I'll talk about that in a little while. And then here's a link. This is also, you can find it, either click on this. It's also in my syllabus, the link to get here, or you all got here, so I assume you know that. And here's another link for my office hours. Also down here is a link to the syllabus. Now, if we go to content, which I'll go now, you click on content. And here's the content. Now, if you notice, I have syllabus, I have lectures, information for the Zoom again. I have a folder called lectures. If I click on that, you'll see various lectures here. The first one we'll do today, start working on, is chapter 2, alkanes. I have it both as a Word document and a PDF document. And I have other things here for you, and these are available for you to download. I also have practice problems, which I have both as a PDF and as a Word document. And I also have the practice problem answers. And look right here. Here's a link, or it opens up to link to my YouTube channel. Let's talk about that since I've got y'all here. Oh, look, it's me. Oh, that was an awful joke. By the way, most of the time, I usually am pretty good at my humor. but sometimes instead of having good humor days, we have bad humor days. And both you and I have to suffer through those. Hopefully today it won't be. All right, what I will be doing, and I'm doing right now, and let me check to make sure I am doing that. Yep, I'm recording. I thought I should, but anyways, I have my Chem 170 YouTube channel, but you didn't know Dr. White was a YouTube star. Not really, but it feels good to say that. And here I have, I think already 3 semesters of organic Chem 170 here. You can see the different weeks and all that. But what I will be doing for our class this summer, by tomorrow morning, usually later this evening, I will create and upload and post here today's lecture, what I'm doing right now. So A, if you want to go back and look at it again and cover something, you can. Or B, if you happen to be late or miss the lecture, you can go here and watch too. So that helps students a lot. And if we scroll back, this little personal thing, if you notice, let's go right here. You can't see it, but I'm wearing glasses. And if you see me now, I'm not. Last November, I had, during the month of November, serious, it was quite serious, cataract surgeries on both my eyes. And my eye surgeon, Dr. Cabin, and his staff were tremendous. Right now, the last couple of months since then, I haven't been wearing glasses, and that's the first time over 50 years I don't need glasses. If you need the name and contact information for a great surgeon, let me know. I'll give you, he's in Hoffman Estates. But anyways, this will always be available to you because it's on YouTube. That's not what I wanted to do. Let's go back to here. And like I said, over here, you'll have everything. Now, since we're totally online, I will be posting assignments in the assignment area. Have you noticed I already got some stuff visible? This is my interface, signature sheet, and the melting point slab, which will be tomorrow we'll have. And if you click on this, let me go to student view, hold on. You go to assignments, and if you look at melting points, I have both the melting point slab as a Word document, a PDF. Now, after the lab, you're going to have to fill out some stuff and upload it here. And I ask students to upload it as a PDF file. Now, if you don't have a scanner, a faculty member taught a couple of years ago, taught me about this. There's a free app called Cam Scammer. Don't spend any money and get their pro version. It's a waste of your money. The free version works fine. And I also have instructions how to take pictures with your cell phone. By the way, you know how some people call it a smartphone? Has anybody ever found a dumb phone? But anyways, with your cell phone, oh, that was awful. I apologize. But anyways, you can take pictures and take those pictures, and the instructions show you how on a PC or a Mac. I'm a PC person. My sister's a Mac. We don't like each other's computers, but that's another story. How to create from your cell phone pictures a single PDF file, and you'll be uploading it. And that's how we do this, and you'll do it for a test. Now, important thing, if you do not own a printer, and a while back, you can't see it right here, I've got a nice, recently only cost me $200 HP LaserJet's black and white, I don't need color, printer. I've had it for a while now, almost a year, but for a while I was without a printer, so I know how it is. You can hand write out stuff on a piece of paper, as long as you can make sure I can read it, or print it, because some of you don't do cursive. Yes, I can read cursive, and upload that as a PDF file by either using CamScan or your scanner or your cell phone. Now, I'll have in here the grade book, which is showing as a student, where I'll post your test scores and your lab scores. And the nice thing is I figured out you'll be uploading your test scores, how to send back how you did on each question you have. I found a way to do that by sending each of you an individual email. And after I give a test back, I always go through the whole test and go through all the answers. Because that way also you can make sure I didn't make a mistake grading. Because the last time I checked, I don't walk on water unless it's frozen. Even then I stay off. Oh no, I've been amiss. I haven't talked about propane. And propane is CH3CH2CH3, propane. It's got 3 carbons in it. It's a small but important molecule, and it's an organic chemistry molecule. Again, propane, CH3CH2CH3. Anyways, that's D2L. If you have any problems with D2L, let me do this. Always feel free to ask me or contact the help group, computer help group at ECC. Those people are very helpful. All right. A couple of things. First of all, I'm going to be going through the syllabus, and then I'll be showing you how to do well, what you have to do well in my class. All right, let's go through the syllabus. One thing, if you notice, we're scheduled to go from 2 until 4:50. Now, normally when we're face-to-face, if this were summer, we'd be doing that. We'd take 10-minute breaks. But since we're on the internet and you don't have to walk 5 minutes to get a snack or anything, because you're hopefully at home, even though I have had students watching me in a car, hopefully they weren't driving. But anyways, we'll take 5 minutes breaks and we'll get out a little early. We will take breaks because I have found, both in lecturing when I've been in industry and also teaching, and also personally, after about 55 minutes sitting, your brain goes to sleep and you need a little break. So I give those. All right, let's go through the syllabus. I'm not going to go through all of it. You should be able to read it on your own. All right, thumbs up, people. Do you see course syllabus on your screen? Uh-oh. Do you see it on your screen now? Thank you, Hannah. And here's the syllabus. Here's the start date, the end date. We will be having lectures Monday, Tuesday, Wednesday, and Thursday from 2 to 4:50. Now, on Tuesday, Thursday, which our lab, will get out a little early. In real life, we would. Now, an interesting thing happened to me about a week or so ago. I was always under the impression, which I think is still a good thing in my mind, that for a synchronous course like this is that I should give the same amount of time in a Zoom meeting as I would if I were face-to-face. In other words, conduct my class just like if we were face-to-face. And I was emailing the dean about something I had a concern about, and she came back to me and said, no, you don't have to. You only have to do about, most instructors do about 2 hours a week. And I said, really? Yep. And I said, okay. guess what? I'm still going to do this. If you can't make it, you can always watch the video. All right. Now I have the links here in the syllabus for the Zoom meeting. I have my YouTube channel. Within 24 hours or less, usually by the end of the evening of a lecture, I'll have it posted to YouTube. So if you miss it or want to watch it again, you can. Here's my office hours. In the summer, I'm not required to have office hours, but I'll still have them. And those are Monday, Wednesday from 6 to 7 on Zoom. And here's the link and the information to log in. Now, what's the best way to reach me? Well, if you look up here, there's a phone number. I can't remember the last time I checked. It's really a voicemail box. I don't remember even the password. It's got to be at least 5 or 6 or 7, 8 years since I've used that. The best way, and it's located here, and it's also in the directory you can find on elgin.edu, the school's internet site, and that is email me. Every day I check my email at least twice a day. That's Saturday and Sunday too. However, I'm an early riser. I get started, and this morning, I think the first time I checked my email today was somewhere around 5:15 a.m. Yes, I get up early. I go to bed. It's something I've done all my life. So email me. That's the best way. All right, there's stuff here that I'm required to put in that I'm not going to go over. I take it out, but anyways, a couple of things. First of all, I don't have it here. I guess I took it out. Here is the textbook, Organic Chemistry, and I've got the 12th edition. I should be getting the 13th edition soon. Don't buy this. You don't need to. The way I teach and with my practice problems, if you go to, oh, I forgot to ask, how many of you have heard about me and ratemyprofessor.com? Give me a thumbs up. Let me go to, well, you'll find out if it's true. It is, but anyways, if you go there, a number of students say you don't need the book. Why? Because of the way I teach my lectures, and also the fact that I give practice problems and practice problem answers. Ooh, I almost forgot something important. Propane, it's still CH3, CH2, CH3, 3 carbons, 6, 8 hydrogens, and that's propane. And that's the gas that's in the white tanks for your barbecue. All right, so you don't need to buy the book. In fact, more than once, because I've got a couple of copies of these floating around when I've been back when we were teaching face-to-face. Well, that was a while ago. But anyways, I'd lend out copies to students who were sort of financially strapped and said, you can borrow my book for the semester. And within about 2 weeks, I'd get it back and they'd tell me, we don't really need the book. I can just come to your lectures. It's much better. So if you want to buy it, this is about everything I cover, or I follow the way the book is written. I cover a lot of stuff that's in there. I also put in some stuff that isn't, because I'm an organic chemist with real world experience. Buy it, but I wouldn't recommend it. Oh, by the way, the first Hart, that's Dr. Harold Hart. When I was a grad student at Michigan State, he was a very famous professor, not for his book, which he made a lot of money, and I don't know if he's still alive, but over the years he did, but for the research he did in organic chemistry. And later in the semester, I'll tell you a Harold Hart story. All right, let's get back to the syllabus, but first, propane, it's still CH3, CH2, CH3, propane. All right, attendance is recommended. Since this is a synchronous internet. I'm not taking attendance, but I really emphasize that to succeed, attend my Zoom meetings or watch the YouTube videos of that if you really want to succeed and get a good grade. Now here, this is a behavior thing about face-to-face, which I really don't have a problem in Zoom. I can just kick you out in Zoom, and it hasn't been a problem. You should prepare before class, keep an eye on it. Then when I say we're going to go over the problem set X the next day, you should work on that before I do. That will help you. All right, nobody raise your hand, do a thumbs up or anything else right now. Let's talk about special needs students. I have been working with the Learning Center for many years, and I strongly support, as strong as I can, any students who have special needs. And I've had a number in my class and they've done well. Please see me in private, contact me, or have the Learning Center contact me. And whatever your special needs, I will try as best I can and always will help you so your special needs are met. Again, I support this fully. And if you do, see me in private or email me. All right, what's important to you? Well, how do I get a good grade in this class? Yes, I was a student a long time ago in a galaxy far, far away. I'm also a science fiction buff. But anyways, there's going to be 4 one-hour tests. Here's the tentative dates. Unless there's a power outage at the school or somebody gives me $1 billion, those are going to be the dates. Don't hold your breath on somebody giving me $1 billion. All right, I'll talk about regrading afterward. On the last day of class, 7/21, we'll have a 2-hour comprehensive final. Relax, take a deep breath. Students do good in my class and the final. We'll have extra credit on the test, and also there'll be 1 extra credit project. Here's my makeup policy. If something happens, you've got an emergency and you can document it some way, I'll allow you to make up a test, but don't abuse it. All right, let's talk about everything. You're going to be doing tests, 4 of them, final. I'll talk a little about the lab reports, and each of those you'll get points. We're going to have 4 exams, and the 3 highest test scores of your 4 tests I add together, which is the maximum of 300 points, 47% of your grade. The final exam is worth 200 points. Relax, students do good on this. That's worth 32%. And the labs, I'll explain later, 12 out of 13 labs that you'll be points added up. That's total 132. And this should be 632. Oh, I made a mistake. See, I told you I didn't walk on water. But anyways, you add it up and it's 100%. Now, how do you get a grade? Their percentage, and let me, so everybody doesn't have to squint. All right, your percentage is calculated, the sum of the 3 highest test scores, your final exam points, your lab total, and an extra credit project, which is optional. Add that together, multiply 100, divide by 632, and you get a number, a percentage. And if your percentage is 90 and above, you get an A, 80, 89, B, 70, 79, C, 60, 69, D, and hopefully nobody in there, or next one, equal 59 or less than F. Now, if you follow, which I'll teach you today, what you should be doing to get a good grade, you will. Over the years, historically, and it's usually even higher in the summer, and I always thought it would be the other way around, but summer students usually do better than fall and winter. But my fall and winter and summer, historically, listen carefully, over 60% of the class, and the key word is earns A's in my class. And most people get A's or some get B's and rarely a C, and on a rare occasion, D or F, if you follow what I'm going to suggest later today. So people do good in my class. You've seen it on ratemyprofessor.com. You talk to many of my other former students, you'll find out they do. Now, here's the withdrawal. Most students don't withdraw because they're doing good in my class. The only few times I've had that happen is when students were pregnant near birth, giving birth to their children. And that's where they got a job outside the Chicagoland area when we were face to face. Here's my incomplete policy. If you've got a reason for an incomplete, especially a situation with COVID-19 going around still, I'll work with you on this. But first, it's time for propane. Remember, propane is CH3, CH2, CH3, and that's propane. And that's the molecule that's in the tanks for your barbecue. All right, thumbs up, people. Everybody see the tentative Chem 170 course line outline on your screen? Somebody give me a thumbs up. I guess you can't. Oh, thank you, Hannah. All right, I will be sticking to this. Here are the different chapters I'll be covering each week. One of the things I'll give you advice right now, what I normally do in 17 weeks, we're going to do it in 7. So it's much faster paced. Don't fall behind. There's no reason to. You have access to my videos in case you miss a lecture. And so please don't fall behind. Remember, on July 4th, which is a Monday, we will not have class. All right, now, what I'm going to do is wait until tomorrow to go through the lab part of the syllabus. Now, at the very end, I have what's called the student agreement. And I actually have on assignment area separate form. This is just in the syllabus. And let me open it up while I'm here. But first, once again, it's time for propane. Propane, CH3, CH2, CH3. So I told you I was going for the Guinness Book of World Records. Propane, CH3, CH2, CH3. Propane. All right, here's what I call the signature sheet. It's in the assignment area for you to download it either as a PDF or as a Word document. And essentially it's a contract between you and me. I learned about this years and years ago. Faculty at ECC were doing it then, and it's a good idea. I'm going to ask you to print your name. You've read the syllabus thoroughly and understand the policies for the class, and you understand it's your responsibility to abide by those policies. And you understand that if you don't, I'm going to do what's in my syllabus, and I will. Hopefully I never will, but every once in a while, it's rare, but over the years I've had to do that. Also, since I'm videotaping this, and not to violate your FERPA rights, and that's an acronym for federal whatever, educational, I forgot what the whole thing is. you understand that I'm videotaping the Zoom meetings and that I'll be posting those on YouTube for public viewing, and therefore you waive your FERPA rights concerning your name, voice, or image to appear in those. By the way, I'm not selling these. No, I'm not going to be a YouTube millionaire. Wish, but you know anybody who wants to buy them, let me know and we'll split the difference. But they're available on YouTube. If I don't have this by the first test, you won't be allowed to take it. That's my rule. It's in my syllabus. All right, any questions? Remember, there's no such thing as a dumb question in my universe. Never. Whether I'm in a class or not, if we were at ECC face-to-face, I tell you, if you see me walking a hall, you got a question, ask, unless I got to get somewhere quick, but I still will get back to you.
I do have a quick question. Are the tests in person or online?
What?
Are the tests in person or
Good question. Thanks. See, I told you there's no such thing as a dumb question. All right, the way I'll be doing a test is the day of the test, after class, or actually the day before the test, in the assignment area, there'll be a password protected PDF file for you to download. After the class, the day of the test, after the class or lab, I will email out to everybody the password for that PDF file, and you can open it up and take the test. Now, what I do, and I've been doing it a while, is you'll have until 11 o'clock the next morning, 11 a.m., to take the test and upload the answers as a PDF file. If you don't have a printer, you can write it on paper, make sure I can read it and put your name on there, and you'll upload that as a PDF file using Camster or the other way with a cell phone. And there's a way with either Windows 10 or whatever the operating system is on a Mac to do that. And that's how you do it. Now, you should know you're dealing with Dr. White, who can be very clever at times. And I put things in my tests to know if students are cheating. Unfortunately, they work. So I've gone the honor system, and I've been pretty, how should I say, happy that students are quite honest about it. Jordan, does that answer your question?
Yes, it does.
Great. All right. Now, I should talk about the math requirement for Chem 170, and it's really, really difficult. I won't even allow you to use calculators on our test. First of all, you have to be able to count, add and subtract. I should say add and subtract up to 4. Next, for the first 2/3 of the semester, you have to know how to count up to 10 and which numbers from 1 to 10 are greater than the others. Like 5 is greater than 3. And guess what? That's the whole math concept you have to know for my organic chemistry. You can all go like that. By the way, when I was an undergrad at IIT, I got my bachelor's degree at IIT, Illinois Technology. I took all the way through because I thought it was fun. I didn't need it. Partial differential equations. Oh, that was a tough course. And then I've never used it again. It was fun, but you don't use that in my branch of organic. All right, any other questions? All right, I have a question for you. I can go to gallery view. For those of you who don't have your webcams on, use the emoji, thumbs up. How many of you here are planning on being a chemist? Give me a thumbs up or raise your hand. How many of you here have an undying love for organic chemistry? Give me a thumbs up or raise your hand. How many of you are here because someone said you had to take organic chemistry to get into a school or a program like nursing? Now, guess what? I knew that, but now you know I know that. And what does that mean? I'm not going to try and convert you to becoming an organic chemist. I am, because I love it. I really do, have for many decades, and it's fun. But you'll find out my world of organic chemistry is your world of organic chemistry. You don't know about it yet. By the end of the semester, you will, which is a good thing, I think. Now, next question is, why learn organic chemistry? Good question. Well, let's think about it. The food you eat, that's all organic chemistry, even though the word organic has been hijacked by advertising to mean a certain quality of food. All food is organic. Oh, my shirt is organic. The dye that is used to make this yellow is organic. My skin, everybody, this hopefully won't hurt. Touch your skin. Go ahead. Come on, it won't hurt. I hope it doesn't. Your skin's organic. My hair and beard, what's left of it, that's organic. So let's see. All my food is organic. I'm organic. My clothing is organic. The plastic of my printer, that's organic. By the way, that's 3 external hard drives. Yes, Dr. White is a computer nerd. But anyways, have been for many decades. But so let's see, everything around us is mostly organic. So isn't it obvious why you should learn organic chemistry? It is, isn't it? Because you want to get a good grade to get into a program or get into school. And I know that, but I'm going to help you learn about the exciting world, my world, which is your world of organic chemistry. And time out for a propane. And propane is CH3, CH2, CH3, propane. Now, after in a little while, we'll be taking our break for 5 minutes, and then I'll come back and I'll tell you what have I been doing with propane. Actually, we've got about 30 seconds till break time. I'm going to let you out even a little bit early. Let's take a break. No, actually it is. Come back at 2:55. I can get up and stretch because I do that after sitting for an hour or 50 minutes. So I'll be back. Please come back. I'll see you at 2:55. Let's get going. All right, welcome back. In case you forgot, propane. See, I wasn't lying. I am going for the Guinness Book of World Record. Propane, CH3, CH2, CH3, propane. Well, one thing I should say, as I said earlier, there's no such thing as a dumb question. If I write something down like here on my whiteboard and you can't read it, ask me, what the heck is that? Also, I have the fastest mouse wheel finger this side and the other side of the Mississippi River. So if you ever want me to go back to something, ask, and I always will. All right, now, how do you get a good grade in organic chemistry? I get everybody's attention. And in order to learn how to do that, I have to talk about bicycles. Bicycles? Yeah, bicycles. Let's assume you don't know how to ride a bicycle. And being the nice person I am, which I am, I give you the world's best Blu-ray on how to ride a bicycle. And you have a monster big high screen definition TV and a really good Blu-ray player, and you put it in there, and for the next month, you watch that over and over and over again, slow motion, frame by frame, till you know that thing by heart. Every picture, every second of that, you know. What's going to happen the first time you get on a bike? You're going to fall off. But with practice, you learn how to ride a bike. Guess what? Organic chemistry is no different. You're going to see me do problems in class and say, oh, that's not that hard. But if you don't do the practice problems by yourself on your own, guess what's going to happen? On the test, you're going to fall off, and that's not going to be pleasant. And I don't want that to happen. So practice. Now, most of you are, well, I just found out, how many of you remember when Michael Jordan was playing for the Bulls? Okay, generation gap time. Well, if you're around here in the Chicagoland area, which I was, when Michael Jordan was the best of the best of the best of National Basketball Association, the NBA league player, he was the best. And there'd always be on TV or in the newspaper, you'd see an article every once in a while, and it'll go like this. Michael Jordan, always the first one on the practice court and the last one off. And this is when he was the best of the best, but he was practicing the most. And that's one of the things that kept him being the best. You have to practice if you want to do good in this class. Now, another thing, and I'm not going to sugarcoat it, there's a lot of memorization in organic chemistry. That's just the way it is. And how do you memorize something? Well, I'm going to ask everybody, close your eyes unless you're driving, but close your eyes. Can you picture propane, the structure? I bet you can. If we were in a classroom, I'd ask how many, raise your hand, can remember it. And if you had said CH3, CH2, CH3, propane, you would have been right. Now, why have I been doing this? Well, I've done it an obnoxious amount of times. Propane, showed it to you, like writing it down. CH3, CH2, CH3, and propane. So visually, I've been writing it, and also I've been saying it. So you've been hearing it auditorily. Now, how do you memorize something? Flashcards can work for some people, but most that don't. The way you do it is if you have to memorize the structure of propane, write it down 5 times and say it. Each time you write down propane, CH3, CH2, CH3. If you're in the library, You can say it silently in your mind, and propane, you'd spell it also. And then you do it a second time, CH3, CH2, CH3, and propane. And you do it 5 times. And maybe a day or two later, you do it another 5 times. You'll have that burned in to your brain. Number of years ago, I was teaching Chem 170 at ECC face-to-face. This was before COVID-19. And after test 1, these 2 students who were close friends, they came up to me after class, and one of them said, I didn't do good on test number 1. How can I do better? I asked, did you write things down 5 times and say them? And she said, that's a lot of work. And her friend looked at her and said, yeah, but I got an A. And the second friend got the message, and the next test she did a lot better because she did that. That's the best way, and it works for most students. If you want flashcards work for you, go ahead, whatever works for you, use it. However, that way is foolproof. Most of my students have really done well with that. Now, another thing over the years that have happened is students who have test anxiety. They study, they do the practice problems, they got them down pat. They go and take the test, and all of a sudden their brain goes, eh. Remember, I'm a chemist, not a psychiatrist, psychologist. However, I did have a student long ago who the first time encountered it, and I came up with a method based on somebody else's method that eliminates test anxiety. I've had that through the years in both Chem 170. I also teach here at times Chem 112 and 101, and COD Chem 1212, 1211, and 1105. Yes, I teach a lot of chemistry courses. And my method takes about 10 minutes to learn, eliminates test anxiety for just about every student, and students go from getting D's or C's or even F's to being B and A students when they eliminate the test anxiety. Yes, you still got to study, but it really helps. This, I think, Thursday, I will teach that. However, I will cut it out of the video. If you need to, come to my office hour and I'll teach you next week, or we'll set up a time if you can't come to my office hour. All right, guess what time it is? It's time to start your trip into my world of organic chemistry, which is your world of organic chemistry. All right, couple things. First of all, I'm going to assume you all have an understanding of the periodic table. And what I mean by that is you should know the following chemical symbols. Mine's pretty simple. You should know hydrogen. Then, let's see, lithium, sodium, and potassium. You should also know, let's see, magnesium and calcium. Then over here, let's see, platinum, palladium, and nickel. That's not their order in the periodic table. Then nitrogen, and the most important one, carbon. If you're an organic chemist, carbon and hydrogen. And then oxygen. And then the halogens, chlorine, bromine, up here is fluorine, and iodine. And what do I mean by no? If I say, let's talk about carbon, you should know in a chemical symbol of carbon is C, nitrogen N, nickel Ni. And I will never ask on a test what is the name or symbol for those, but I'll be using these in class. And really, that's mainly my periodic table. I could throw in 1 or 2 more, but I don't think we'll use it. But those are the important ones. And what I mean by that is when I write propane, Yeah, you still remember that? You know that these C's stand for carbon, these H's hydrogen, and notice the subscript means there are 3 hydrogens on that carbon, but I'll teach you more about that. All right, next thing, the way I'll be doing it this whole semester, and this is classic way I teach, which works well. If you've taken organic chemistry at other schools, they do different ways, which don't do well. In fact, I have the reputation at the University of Illinois, Champaign-Urbana, that when I teach at either COD or here, the counselors there, and I found out a couple of years ago, I blew my mind, are telling students, wait until you come back to Chicagoland and take it with Dr. White. This is before it was on the internet. Now I've had students throughout the United States take me. If anybody's out of state, email me. I'd like to know where I'm broadcasting to. But anyways, I'm going to be talking about what's called functional groups. And functional groups, and I'll never ask this on a test, are a collection of atoms in a molecule that have the same chemistry and similar physical properties. Example would be a oxygen with a hydrogen. This is, I'll teach you later on, hydroxyl group on a carbon. This functional group is called an alcohol. And this we'll go through. And alcohols have certain chemistry and certain physical properties. And we'll be going through, just like if you are sitting on a chair right now, you know what it's used for. If you go to the library at ECC or a classroom, they have different chairs than the one you're sitting on, but you know what the functional group or function of a chair is. And that's how we'll be doing this. I'll be teaching you different functional groups, and you'll see once we get into it how I'll be doing it. And let me just remind you, remember, there's no such thing as a dumb question in my universe. Oh, one thing I forgot to tell you is I'm a very selfish person in certain ways. And the way I'm very selfish is I like good things to happen to me. It makes me happy, and I like to be happy. One of the things that makes me very happy is to see students succeed. And I will do whatever I can to help you to get the best grade. And listen carefully, you're willing to work for in my class. Again, I'll do whatever I can to help you work to get the best grade in my class. And that's my promise. In fact, my fervent dream is to have a class that gets all A's. I've come close. In fact, one summer I had 24 students in the class, and I had 22 A's and 2 B's. I was so upset at first. I'm saying, I wish they had gotten A's. So I realized if I hadn't helped those 2 students out and given them some extra help, they would have flunked. And by encouragement and extra help and showing them how to do better on tests, they got B's. And going from an F to B, that was quite an accomplishment for them. So that was amazing class. And I hope you're an amazing class. Last semester, I don't know what it is, but I seem to attract people who do well in my class. All right. Now, I'm going to be showing you slides on the screen. And when I was in industry, I lost count how many PowerPoint presentations I gave, like the CEOs of companies I was working for, or high-level meetings, or at conferences I would go to. I don't in this class. It's easier for you to see it as either a Word document or a PDF. And whatever I show on the screen from now on will always be available in Blackboard, wrong school, D2L. I said I would make that mistake, and I did. Say I don't lie. In D2L, but if it's something I write on the screen, you can always go back and look at the video. And if you want me to, you can always ask me to go back and show you something again. Let's hold on, I got to open it. All right, everybody see chapter 2. By the way, chapter 1, they have in the book, which I don't do, they go through all the functional groups. And guess what? You're going to forget them. I'm going to do each chapter, and that's a better way of learning them. All right, thumbs up, people. Everybody see chapter 2 on your screen. Thank you. All right, let's go through and start your journey into organic chemistry. And we start out with the alkanes and cycloalkanes, which I'll teach you what that means. Now, when we start out, let's talk about hydrocarbons. I know you've all heard it in the news when they talk about hydrocarbon pollution. What are hydrocarbons? So, and I'm going to assume you know what a molecule is, collection of atoms held together by chemical bonds. What is a hydrocarbon? That's a molecule with only carbon and hydrogen atoms. Now, I should warn you, I can be very subtle at times, and this is a time I should be subtle. Subtle? You should know, and there's some definitions I'd like you to know. What is a hydrocarbon? And what I mean by that is I can ask an exam, what is a hydrocarbon? And all you have to put down is molecules with only carbon and hydrogen atoms. And that's a hydrocarbon. Speaking about my test and final, there's something I should share with you. I have never, ever given a multiple choice question on a Chem 170. In other classes I teach, I rarely use multiple choice. As a student, I hated them. Luckily, when I was a student, they weren't that popular. And multiple choice are designed to trick you. My tests are designed, did you learn the material? Show me. And it's much better, and students do much better. I don't trick students on a test. But you do have to study and learn it, do the practice problems. Ooh, I should tell you, don't tell anybody, but after test number 1, you'll understand why I call them practice problems. Hint. All right. So hydrocarbons are molecules with only carbon and hydrogen atoms. An example of one, oops, wrong color, right color, is propane. Propane is a hydrocarbon. Notice it only has carbon and hydrogen atoms in there. Now, when we talk about hydrocarbons, there's 2 types of hydrocarbons. One is a saturated hydrocarbon, and the other is an unsaturated hydrocarbon. And I think I'll be subtle again. Hint, know this. And what's a saturated hydrocarbon? That's a molecule with only carbon and hydrogen atoms. That's what a hydrocarbon is, in which all carbon-carbon bonds are single bonds. So saturated hydrocarbon has only carbon and hydrogen atoms, and all the carbon-carbon bonds are single bonds. And remember what you see on the screen here, other than my hint, you can download from G2L. I have it secretly named Chapter 2 Alkanes, and that's in the lecture folder of G2L. Now, just a quick reminder, in case you forgot, we talk about covalent bonds in chemistry. Okay. There we go. Everybody see me writing single, double, and triple on the whiteboard? Thank you. And remember, there are three types of covalent bonds: single bond, one pair of electrons being shared; double bond, two; triple bond, three. And we show a single bond by one line in organic chemistry. I'll go over this again. A double bond is two lines, and a triple bond, three lines. And you should know at least that a single bond is one pair, double bond, two pair, triple bond, three pair. If you haven't figured out by now, I go and do a lot of repetition because that's good for your grade, which I think is a good thing. So if we look at propane, between the carbon atoms, there's a single bond. And therefore, propane is a saturated hydrocarbon. And if I ask on a test, what's a saturated hydrocarbon? That's a molecule with only carbon, hydrogen atoms, which all carbon-carbon bonds are single bonds. And you should know this. It even says that on the screen. Oh, that was bad. Sorry. But anyways, the other type of hydrocarbon is an unsaturated hydrocarbon. And unsaturated hydrocarbons, because their hydrocarbon molecules have only carbon hydrogen atoms. So they're molecules with only carbon hydrogen atoms. Now, the unsaturated means they contain one or more carbon-carbon multiple bonds, otherwise known as a double or triple bond. And I'll teach you later molecules that have double and triple bonds. You can even find some in your grocery store in the produce department. Really? Yep. Bet you didn't think you'd find out about organic chemistry where you can get celery, carrots, and onions, but it's there. All right. So you should know saturated hydrocarbon, molecule with only carbon, hydrogen atoms, in which all carbon-carbon bonds are single bonds. And unsaturated hydrocarbons, because they're a hydrocarbon, are molecules with only carbon and hydrogen atoms that contain one or more carbon-carbon multiple bonds, otherwise known as double or triple bond. I guess except that I asked you what's an unsaturated hydrocarbon, you could also put down molecules with only carbon, hydrogen atoms that contain one or more double or triple carbon-carbon double or triple bond. And the unsaturated means you can add more hydrogens to fully saturated. And we'll learn about that later this semester. And way later, how many of you have heard that unsaturated fats are healthier for you than saturated fats? Anybody? Give me a thumbs up if you have. You haven't? Oh, no. But I'll teach you about that. And that means in certain things, if there's a double bond, it's unsaturated, makes that fat healthier for you. That's an industry Dr. White worked with, fats and oils. And I'll talk more about that later in the semester. Now, you're going to learn a lot of neat words you can impress your friends, neighbors, and loved ones with in my class. And the next thing I'm going to talk about are alkanes. Now, I'll never ask on a test, and you've got my word, and also it's on the videotape, what is an alkane, but I'll use that terminology. And that's an acyclic saturated hydrocarbon. Acyclic, what does that mean? Well, cyclic means circle, or we call it a ring. The prefix A means without. So this is a saturated hydrocarbon, molecules with only carbon and hydrogen atom that are not in a ring. They're straight, or as we say, in a chain. And I'll never ask this on a test. Now, certain entrance exam tests ask you about this formula. I will never ask this on a test. There are more important things I can ask on a test. And all alkanes have the formula CnH2n plus 2, where N is the number of carbons. And let's see if I'm telling you the truth. Here's an alkane. Propane. It's got 3 carbons. Therefore, if I use this, 3 is here. 2 times 3 is 6, plus 2 is 8. So it should have 8 hydrogens, and it does. And that's the saturated. And I'll never ask you that, but somebody told me more than once that in certain nursing exams and others, I asked that stupid question in my mind. Now, another molecule, CH4, is methane. And here it looks flat. But in reality, it's in 3 dimensions, just like you and I are in 3 dimensions. Here's a model of one. And the center right here, there's my carbon, and each one of these spheres at the end are my hydrogens. And this shape is called tetrahedral, and it plays an important part in our daily life, including your hormones. We'll learn about, yep, I'm going to get into that later on. Here I have some models. This is called, whose name is, I can't think of it right now. But in here is the carbon. And at the end of each rod, think of a hydrogen. And this is called tetrahedral. The bond angles are certain 109.8, I think. So that I'll never ask on a test. Now, when I was in grad school, my advisor, who I will always be forever grateful for, Dr. Roosh, had a very expensive set of called Dryden models that when you put them together, you could measure the lengths between like 2 atoms. And that would be the actual angstroms in real life. And they were like about $50 in that carbon. And if you wanted to borrow his set, he'd always say, be careful, don't ruin it, don't bend anything. And you were. They were nice to use. See, I'm an organic chemist. So carbon or molecules are in 3 dimensions. This is in 3 dimensions. Now, if I put a lot of carbons together, it's not straight, even though on the board I'll write it straight. It's zigzag because of the geometry of carbon atom in a single bond. Double and triple bonds have different ones I'll teach you about. And here's some alkanes, methane, ethane. The only time I've ever seen that used is, how many of you have ever seen at a sports event, somebody injures their wrist or ankle and the trainer takes out a cylinder, sprays something on it, and all of a sudden it's better? Well, that's ethane. It's gas at room temperature, but it's under high pressure. It's a liquid. As soon as it evaporates, it takes energy and it cools down the skin. Oh, look, it's your old friend propane, CH3CH2CH3. And these are all alkanes, only carbon, hydrogen atoms, hydrocarbon, and saturated, only carbon-carbon single bonds, and they're acyclic, not in a ring. Is everybody done copying this? You don't have to at this point. If I move too quickly. Now, there's something called cycloalkanes. And cyclo, how many of you have heard the term bicycle? Bi means two, cycle, circles. A bicycle has two tires. Profound. Anyways, a cycloalkane, well, they're saturated hydrocarbons, which the carbon atoms are connected together to one another in a cyclic arrangement. And organic chemists call that a ring. And I'll never ask you the definition of what is a cycloalkane, but I will use it in class, so it's good for me to talk about it. And it has the general formula CnH2n, which I'll never ask you in class. And here I have a ring. You notice there's 1, 2, 3, 4, 5, 6 atoms, carbon atoms. Here are my hydrogens. We'll learn more about that. And this is a hexagon, but we call it a ring. And if you notice, it's not flat like a piece of paper, even though some rings can't. And I should be honest with you. First of all, I forgot to mention this. Everybody, do you know who's the greatest, one of the greatest of all organic chemists? Mother Nature. She by far has done some amazing organic chemistry. Well, it's time for me to tell you something. Mother Nature and Dr. White loved rings, especially 6 and 5 carbon rings. They're in your body, they're in our nature. Mother Nature and Dr. White loves them. My PhD thesis dealt with a very specialized ring system called bicyclo 222 octanones. Oh, that was a good time in my life, sometimes, a lot of times. Now, one of the most important things you'll be doing in my class, and more importantly on tests, is drawing organic molecules. Now, there are different ways to draw organic chemicals or molecules, and one is called the condensed structure. And this shows how atoms are connected together, but does not show always, even though I do carbon-hydrogen bonds or sometimes carbon-carbon single bonds. So let's look at this. Everybody see propane on the whiteboard now? Thumbs up, people. Thank you. You'll get the hang of it. Anyways, this is an expanded way of writing propane. This is one of the rare times you'll see me do this. It's a lot of extra work. Now, if we look at this carbon, now you got to know how to count up to 10. how many hydrogens are there? 1, 2, 3. So I'll write the carbon, and to the right, I'll put a hydrogen. How many? Subscript 3. Now, you don't have to put a line, but I do, because I found when I was writing in a whiteboard in a classroom or on mine, on the computer here, if I don't put a line, my molecule atoms start falling to the ground, drooping to the ground. This helps me do it. Now, let's look at this carbon right here. How many hydrogens do you see? 1, 2. So I have my carbon, and there you have it. And finally, this last one, how many hydrogens? And I'm going to let you first put the number there, and then I will. Hopefully, I'll put 3. And this is called the condensed form. And this is the one I'll mostly use in class. Now, there's another important way of doing it, which I won't do until about the last couple of weeks of the semester. And that's called the condensed structure with formulas. By the way, I'll never ask on a test, what's a condensed structure or what's a condensed structure with parentheses, but you should know how to write those and use them, and we'll practice that. Now, condensed structure with parentheses is the same as condensed structures, but use a pair of parentheses and a number to show a repeating unit of a molecule. So let's look at how, Seaboard for examples. I better get to work. Now, this molecule is called octane. Why do I think of a gas station? I'll talk about that later. And if you notice right here, I have these CH2 groups repeating. And how many do I have? 1, 2, 3, 4, 5, 6. So using parentheses, which I won't do in class, but you can feel free to, I have my CH3 group, then I have 4, and these are called methine, which I won't teach in this class, but CH2 groups, and you show those 6 of them by putting the group that's repeating in brackets, and to the right subscript, put the number times it's repeated, then we have this last CH3 group. Until we get near the end, when we're going to have long molecules with 18 carbons, this is easier and quicker to do. I'm going to always, until we get to that point, use this way. Now, there's one other method which you can use, and I know how to use, but students make mistakes with it. Oh, I don't have it here. And that's called the line method. And the line method is four carbon alkane is called butane. That's the stuff in the liquid in those lighters. But the line method is every bend in a line, every end in a line is a carbon. And this is the line method. Since you're all rookies in organic chemistry, this can be very confusing, and I don't use it. Yes, I can use it. Other than I'll talk about rings, we'll use it then. Now, cycloalkanes are represented by polygons, and polygons mean many-sided objects. Poly means many. Now, here the rules are every bend in a line is a carbon. And if you have an intersection, end of a line is a carbon, which I won't use that. And an intersection of a line is a carbon, I won't use that. And hydrogens, like I forgot to mention, are not shown. So let's look at how do you draw a cycloalkane. Everybody take note. This is probably the only time this semester I'll be drawing out a ring with all the carbons and hydrogens because it takes a lot of time. By the way, I've been doing this a little longer than you have, so my rings might look better than you when I do them in the line method, even though, you know how you have good hair day, bad hair day. Sometimes I have good ring drawing days and others bad. For tests, I use, in my slides, I use software. It's called ChemDraw. This is how you rarely will see an organic chemist. Here's, oh, good ring drawing. Notice here, 1, 2, 3, 4, 5, 6 carbons. 1, every bend in a line is a carbon. 2, 3, 4, 5, 6. And that's how you do it. Now, there are mainly 3 ring systems that are found in nature mainly. 6-membered, 5-membered. By the way, when we talk about this, I'll teach you about this. Whenever I see a 5-membered ring, I think of a little greenhouse in Monopoly. And a 4-membered ring, no, that's not a square. In organic chemistry, we call that a ring. And a 3-membered ring, no, that's not a triangle. In organic chemistry, we call that a ring. And those are the rings, and you should know how to draw them. And we'll do this, and we'll practice a lot in the next couple classes. All right. One of the things I haven't done yet, but I'll do now, every once in a while, I'll do this. I'll say, click, the switch is off. This won't be on a test, or click, the switch is on. This will be on a test. Because I found when I was a student, I couldn't read my professor's mind. I'll bet what? You can't read mine. Let's do an experiment. Everybody, can anybody think about what I'm thinking about? No, it wasn't rings. It was phenolic resins. So you can't read my mind. A scenario I worked in one company. But I'll do switches off. That means something I'd like you to know about, but I'll never put it on a test. And that's the term isomers. Click, switches off. I'll use this term. Isomers are compounds with the same molecular formula, but different structural formulas. An example of that would be this. Huh. These are isomers. They have the same number of carbons and hydrogens, 5 carbons, 5 carbons, and the same number of hydrogens, but they're different. They have the same molecular formula, number of carbons and hydrogens, but they have different, this is called structural formulas. And I should tell you a story. A number of years ago, I was watching TV, cable, and I was in my family room. I see a commercial for a company that sells perfume. By the way, perfume is very, very sophisticated organic chemistry. And I'll talk about that later in the semester. And the name of the company was Isomers. I almost fell off my laser boy laughing so hard. It couldn't have been more creative. Isomers. All right. All right. Now, when it comes to organic chemistry, one of the more important skills in organic chemistry to have, and you should know for a test, is how to name compounds. And we have a very fancy name for naming compounds, and that's called nomenclature. Nomenclature is this naming of organic compounds. Now, it turned out back about 1905 or 1910, on water break, that people were finding out we're having a lot of problems, like in legal documents or just in communications or patents, identifying the names and knowing what somebody's talking about for a molecule, all chemicals, but mostly organic. And because of that, an international group was formed by treaty between nations, the United States and 137 other countries signed that treaty because of World War I, it was held up. And after World War I, this treaty was signed. And that treaty created an international group whose main function in life was to come up with rules how to name molecules. And most of their rules are organic molecules. And the name of that group was International Union of Pure Applied Chemistry. Sounds cool to say that, but I'm a chemist, but everybody calls it IUPAC. I'll never ask you what IUPAC stands for, but I think it's just cool to say International Union of Pure Applied Chemistry. I just did. And that's the organization that was set up by that treaty. IUPAC headquarters is located in Geneva, Switzerland. And if you notice, I went to Google, my favorite search engine, and you have IUPAC, International Union of Pure and Applied Chemistry. And here's their website. And their website has the rules, if you know, where they do other things now too. And IUPAC was set up to come up with rules which organic chemists and all chemists follow. They're mainly, a lot of it's for contracts between companies, also for legal documents like patents, and also for communication publications to communicate. So that way I know if I'm communicating with another organic chemist and I talk about propane, CH3, CH2, CH3, you know what I'm talking about. And part of the class this semester will be learning the IUPAC rules for certain types of functional groups or molecules. And test one, 50 points out of 100 will be, if you don't know the IUPAC rules for certain molecules, you've just lost 50 points. But I'm going to help you learn how to do that. That's my job. And hopefully I'll do it well. Oh no, time flies when you're having fun with organic chemistry. It's time again for a break. Let's take a 5-minute break, come back at 3:50. That's when the big hand is on the 10. And I'll see you in 5 minutes. I'm gonna get up and stretch again. See you in 5. Time to get going again. Sorry, I was running a minute late. I have to run down and get another bottle of water. All right, let's continue. We're talking about nomenclature. And thumbs up, people. Can everybody see that on your screen? Nomenclature. Yeah, anybody want to turn on their webcam, please do. But anyways, when we talk about IUPAC names, there's certain IUPAC nomenclature rules, which I will be teaching you. And the first one is for continuous or straight chain alkanes. Why do we call them chains? Because they're linked together. Oops, I better do something quick. Microsoft Word doesn't like organic chemical names, even if you put them in your dictionary. So I'm shutting off the proofing so you don't see little squiggly red lines everywhere. All right, now here I have, it's from your book, but I have something better. I'll show you the names of the first 10 unbranched or continuous chain alkanes. If you go to the lecture folder, you'll find both a Word document and a PDF, alkanes, IUPAC names. Everybody see that on your screen? And notice propane has 3 carbons. And you should know this. It's a PDF, and I don't have this. I'll have to set it up. But you should need to memorize this. If you don't know this chart, you've just lost 50 points from test number 1, 35 points from test 2 and 3, not that many on test 4, and about 35, 40% of the points on the final. How do you memorize this? Write it down and learn the number of carbons. Methane, 1 carbon. Ethane, 2 carbons. Propane, 3. Octane, 8 carbons. Remember I had that earlier? Decane, 10. Now the list goes on, and I know I'm higher, but in real world, this is sufficient. This is all you really have to know for my class. Now, it's time for me to teach you something about how to draw molecules in this class. And that is, and this is very important, remember, there's always 4 bonds to carbon. Hold on, let me fix that finger. 4 bonds to carbon. 4 bonds to carbon. I mean, I'm ambidextrous. 4 bonds to carbon. There's always 4. 1, 2, 3, 4 bonds to carbon. What do I mean by that? Let's take a look. Propane has 3 carbons. How many hydrogens on each carbon? Good question. The line here is a bond. To this carbon, how many lines do you see? 1. How many should there be? 4 bonds to carbon. It's time to do real high-level math. 4 minus 1 equals 3. So this has 3 hydrogens. Let's look at this carbon. How many bonds do you see? 1. How many should there be? 4 bonds to carbon. 4 minus 1 is 3. So there's 3 hydrogens. Now, I'm going to share the fun. Let's look at this carbon. How many bonds? I'm going to ask rhetorical questions. I'm not asking you to answer them out loud if we were in a classroom, but if you want to, feel free to, but you don't have to. How many bonds to that carbon? I'm going to give you 8.2 seconds, now 6.1 seconds, go. How many bonds to that carbon? And the answer is 2. 1 here and 1 here. How many bonds should there be to carbon? 4 bonds. 4 minus 2, ooh, high level math, hopefully I'll get this right, is 2. My first grade teacher would be happy seeing I know my math. I did then too. And that's how you do it. Let me rewrite it so it looks nicer. So remember, there are 4 bonds to carbon. And if I were to ask you, hint, 3 points each, sometime in the future, something called a test, 3 points each, draw the structure for butane. How do you do that? Well, you have memorized, remember, I have secret things to know if people cheat and look at their notes or other things that don't work quite well. You've learned this chart. Butane, how many carbons? 4. Well, how do I draw that? Remember, this chart is for the alkanes, acyclic hydrocarbons. So now I know butane has 4 carbons. So I'm going to draw them out. But now I have to put in the hydrogens. And there's 4. Yes, 4 bonds to carbon. So if we look at the first carbon, how many bonds does it have? 1. 4 minus 1, high level math, is 3. So there should be 3 hydrogens. If we look at the second carbon, how many bonds to that? 1, 2. How many bonds should carbon always have? 4. High level math time, 4 minus 2 is 2. I have 2 hydrogens. If we look at this carbon, it has 1, 2 bonds to it. Count the lines from the other carbons. And how many bonds should carbon have? 4. 4. I can do it at the same time. 4 bonds to carbon. So 4 minus 2, oh, look, I've already got it. And there should be 2 hydrogens. And finally, the last carbon here, how many bonds do we see? 1. How many bonds to carbon should there be? 4. 4 minus 1, oh, it's on the board here already, is 3. So this would be the answer. Or you could have like this, either way, that would work. Now, I like to share the fun, so I'm going to let you try one. And what if I were to do this? Draw the structure for pentane. Well, you've memorized this chart. Hint, you've memorized this chart. Big hint. Pentane, how many carbons? 5. Pentane, 5 carbons. But now you have to draw pentane. So pentane has 5 carbons. And I'm going to help you out. It's acyclic, meaning there are 5 carbons in a straight chain. And I'm going to let you have fun now. You draw in the hydrogens, then I will. Your turn. Get to work. Remember, 4 is 4. Let me fix that finger. 4 bonds to carbon. Now, if we're face to face, I'd say, look up and smile when you're done. But let's see if I still have it on here. No, I don't. No, I'll have to do it later. I forgot to, when I set this up, to set up my poll. So. All right. I'll give you another 8.7 seconds. 7.2, 7.4. Time's up. All right, let's take a look at this. How do you do it? There's always 4 bonds to carbon. If we look at this carbon, there's 1 bond. 4 minus 1 is 3. So that tells me I have 3 hydrogens. If I look at this carbon, how many lines to it? 1, 2. So there should always be 4, yes, 4 bonds to carbon. 4 minus 2 is 2. So there's 2 hydrogen. Same thing here, 2 bonds. There should be 4 bonds to carbon, and therefore 4 minus 2 is 2, and there's 2 hydrogen there. And next one here, there's 1, 2 bonds to carbon. There should always be 4 bonds to carbon. 4 minus 2 is 2, so that will have 2 hydrogens. And finally, this last carbon on the right has 1 bond, but there should always be 4 bonds to carbon. So 4 minus 1 is 3. And this is it. And I'll write it nicer so you can see it. And notice each one of those carbons now has 4 bonds to carbon. If you find a molecule with 5 bonds to carbon or 7, let me know. We'll be rich beyond my wildest dreams, which goes beyond having my own islands in the South Pacific and my own Lamborghini and Ferrari. Yes, I've been in a Lamborghini and Ferrari. No, I've never owned one, but I've been in them, nice cars. All right. Now, when it comes to nomenclature, there are 2 skills. One is, here's the name, draw the structure. The other one is, here's the structure, give the IUPAC name. And on a test, I'll never ask you what IUPAC means, but you should know that means the official name. And you would see this on a piece of paper on the PDF file. And how do you do that? Well, you see, this is a straight chain hydrocarbon, an alkane. And how many carbons are there? 1, 2, 3, 4. Now, you have memorized, and I'd get on it right now. That's why I sent out an email to those who registered earlier to start memorize this. We're looking for 4 carbons, and you see 4 carbons, butane, 4 carbons, butane. So the IUPAC name for this, to get your 3 points, you would write down butane. See, it wasn't that hard once you know that table. And what would be the IUPAC name for that? Might look familiar. how many carbon atoms are there? 1, remember C is carbon, 2, 3. And if we go back to here, what's 3 carbons? What's the IUPAC name? And the answer is propane. So you would write down and since I'm going to share the fun, if I say fun enough times, you'll believe me, it is, but you got to be convinced. Now, for C, what would be the IUPAC name? Now, the first thing I ask you to do is figure out how many carbons. I'll give you a 4.8 seconds. Go. R in molecule and C. All right, hopefully you all counted 6. 1, 2, 3, 4, 5, 6. We're just looking at the carbons, the letter C. Now, to get the IUPAC name for that, you have memorized alkanes, IUPAC names, and number of carbons, atoms. I would get on it real quick. Summer moves quick. You fall behind. It's not going to be pleasant. It won't be good for your grade either. So what's the IUPAC name for 6? I'll let you find it on the chat on that table first. And the answer is hexane. So this would be hexane. And that's how you do it. Now, a while back, I had 8 carbons, octane. And it's time for a public service from Dr. White, me. At one company for a number of years, I was section head of process and product development, new product development, all of North America for the nitrogen derivatives for ExoChemi, which was a major international company. And part of my job was I went to companies that made gasoline and sold them, otherwise known as petroleum companies like Shell. Back then it was called Standard, now BP, and Mobil. And the company I worked for sold certain additives that those companies bought from us to put in their gasoline that are sold at the pumps at the gas stations everywhere here, like in Northern Illinois, like by your house. And I got to know about gas from those gasoline from those people. So I'd like to share something to you. All right, listen carefully. This is my own personal opinion, but a lot of people in the gas petroleum industry feel that the same. Shell is the best gas. Next, Mobil is almost as good. Some of the gas like Marathon is very close to Mobil. The worst gas is BP. Unless my life depended on it, which I hope it never does, I will not go into a BP gas station. Why? Because a number of years ago, well, among other things, it's got a reputation as being the worst. About 3 or 4 years ago, in Northern Illinois, Indiana by Gary, that whole area on both sides of the border, BP shipped some gas to those gas stations that was so bad, it destroyed the car engines of about 4,000 cars. Yep. And whoa, no, I don't want their gas. But that's my personal opinion. Now, if you've noticed, and the price of gasoline has gone through the roof. Hopefully it'll come down. But there's a great website, if you're not familiar, it's called ChicagoGasPrices.com. And I use this all the time, have been for many years, and this is why I'm sharing with you. You put in a zip code, like for the Elgin area, is 601. And you'll see if I were at ECC, this shell on McLean and Fleetwood is right by the college, Marathon. They're quite good. And I usually go to that shell. That's not the Marathon across the street. I wonder if I haven't been there in a couple of years. I wonder if it's still there. But anyways, you can go to different zip codes around your house. And sometimes you can see a gas price, and I'm in the Schaumburg area. You can see prices are higher, certain, look at that difference in prices. And by this, you can save 20, 30, 40 cents a gallon by just driving a little farther from your house or where you work or go to school. And again, this is a ChicagoGasPrices.com. Now, one other thing I should share with you. If you notice, there are different types of gas by the octane number. And octane number, originally back in, this won't be on a test, but it's for you to know about. Back when they first came out with cars, 1905 or so, gasoline, some of it wasn't that good. And they found the gasoline that had the most isomers of octane, 8 carbons, alkane, gave the best performance, the least knocking and everything. And that's where they came up with the octane numbers. Now, if you go and look, the gas comes in 3 grades. Unless you're driving a high performance, a very, very expensive car like a Maserati or a Lamborghini or a Ferrari, you can get by with the lowest grade gas. Now, what makes them different? Different additives. The more additives and the higher octane number, the more expensive. Now, what I do, and I've been doing this for many years, and I got told about this when I started going to these petroleum companies, and that is about once every 3 or 4 months, I usually, and this is my own preference, I don't let my gas tank go below half, but I let it go down to a quarter left. I never take it down to empty or near empty. That's just my personal. But I'll do that, and I've been filling up with the regular gas, but about a couple times a year, every 3 or 4 months, I'll let it go down, then I'll fill it with the highest octane. And that has the best additives that help clean your engine and keep it running. And I've got an older Explorer that runs, better be quiet, but runs good. And I do that. And that's my little public service gift to you. Later in the semester, I'll teach you other things like how to clean out your clogged sink pipes in the kitchen or bathroom, what's the best product, and also Dr. White's method for cleaning a caked up bathtub in about 6 or 7 minutes of your own time, most of it just waiting, using organic chemistry. But seriously, you need to start right now, today and tonight or tomorrow, memorizing this chart. You should know methane 1 carbon, ethane 2, and so on, heptane 7, nonane 10, decane 10, nonane 9. Sorry about that. By the way, dodecane is 12 and undecane is 11. It goes on and on. But these are the main ones you should know, like if you want to do good in this class, which I hope you do. And if you notice, I know these names. And what I mean by structures is, you know there's 4 carbons, you know how to draw it, and you know there's 4 bonds to carbon and how to put that in. Now, there are a series of rules for alkanes, and I'll never ask on a test, what are the rules? I will ask you to know how to use the rules that come up with names or draw structures from names. When it comes to nomenclature, there are 2 main skills organic chemists have. for IUPAC nomenclature. And that is the first one. Here's the molecule, what's the IUPAC name? And the second one is, here's the name, draw the molecule. And as I said, on test number 1, about 50 out of 100 points will be doing that. Hence, so you have to know that chart. Now, alkanes without branches, and I'll explain what that means, branches, in a minute, are named according to the carbon atoms, like I had this table right here, which you should know. And that's how you do it. And we just did that. We'll do practice problems also. Now, for alkanes with branches, you have to know the root chain is that of the longest continuous chain of carbons. What does that mean? Let's take a look. And notice I am following, there's 4 bonds to carbon. After today, your solemn responsibility being a member of my class, if you see a structure and I wrote it wrong by not having 4 bonds to carbon, let me know so I can correct it. And I'll thank you. And a skill which is tested for, what is the IUPAC name for the following molecule? And notice not all carbons are in a straight line or chain. We have this CH3 group branching out. And the reason they call it branching is if you go outside and look at a tree, you have the main trunk, then you have things coming out. And those are called branches. Well, they took that name and used that concept in organic chemistry. Now, here we have a molecule, and in order to get the name, the first thing you have to find out is what's the longest continuous chain of carbons, and they don't have to be in a straight line. How do we do that? Well, you start counting. And if I just count across, this carbon is bonded to this and so on. 1, 2, 3, 4, 5, 6, 7. Each carbon is connected to each other. We don't count this one that's branching off. Now, how many of you have ever seen a chain like the one I'm wearing? Hold on. See the chain I have? It's links like that. Or if you have a bicycle chain, and you know it can be straight, but if you go like this, you can crunch it all different ways. Well, organic molecules don't have to be straight. And here we have a branch. But in order to find the longest chain, what carbons are bonded together or linked? Now I have one chain, which is 7. Now this carbon is bonded to this carbon, is bonded to this carbon, and is bonded down here to that carbon. And they're linked by this bonds. And that would be 4 carbons. So that's the second possible chain. And finally, last one I'll talk about. I can start with this carbon, goes to this carbon, goes to this carbon, goes to this carbon, goes to this carbon, and goes to this carbon. So there are 3 possible chains, and you have to identify first which is the longest, which has the highest number of carbons. And now you have to use that high. Remember, I warned you, math is tough in my class. Which number is the largest? 4, 6, or 7? Time's up. Hopefully, all pick 7. So the longest chain is 7 carbons. So let me get my eraser. So this I'm not going to use. This I'm not going to use. So the longest chain are these 7 carbons. And what do we call 7 carbons? Well, hint, hopefully you're going to learn this table. And 7 carbons is heptane. 7 carbons is heptane. And that's called the root name. So I'm going to put down heptane. One thing I should warn you, like today and tomorrow, next day or so, just go, oh, I don't know what's going on and everything. But all of a sudden you'll say, oh, that's not that hard. I get it. If you don't, always feel free to come to my office hours. Or if you can't come, let me know and I'll try and make time on Zoom because I don't have to go to ECC. You don't. Now, do I have all the carbons accounted for? And the answer is no. This is left over. And we call that a substituent. And I'll never ask on a test, what's a substituent? So for alkanes with branches, we found the root name. Now I'll go through other of these. And groups attached to the main chain are called substituents. Now, there's a certain special type of substituent, saturated substituents with only carbon-carbon single bonds that contain only carbon and hydrogen atoms, and those are called alkyl groups. And I'll never ask on a test, what is an alkyl group? Now, one way of doing alkyl group is the alkyl group is named by taking the name of the alkane, same number of carbons, and changing the A and the ending to YL. That's confusing. So what I have done if you look in D2L lecture folder, there's a file secretly named key alkyl groups, both Word and PDF, and here they are. Now, see the line here in the first one? Everybody see that? Thumbs up, people. You see my cursor under it? Can you see the alkyl groups? Yep, you should. And I have CH3 and a line. That means this alkyl group, CH3, is bonded to the main chain. And that's called the methyl group. And therefore, if I go back and look here, notice our substituent here is CH3, and that's called the methyl group. So in front of the root name, we write the alkyl groups. This one only has one. Now, a bad habit of mine is I mix cap and lowercase letters together. If you were keyboarding this, which you're not because you'll be writing on my test, it's easier than using a keyboard, those would all be same lowercase. But if you do either one, I won't care. I better tell you something. I am this close to the person who grades the test in a final, me. So if I tell you, if you do it either way, you know you can. So we have a CH3 group that is called an alkyl group, and it's a methyl group. Now, as I said in the email that I sent out for those of you who were registered early and you should have gotten it, or you can see the announcement, you need also to memorize this group or this table. Now, there are many different alkyl groups, but I picked out only a couple. You should know CH3 bond to something is called the methyl group. CH3 in the line means it's bonded to something else, so there would be 4 bonds to carbon, is methyl. 2-carbon alkyl group is called ethyl. Now, 3 carbons, there's 2 possibilities, and we'll practice this, so take a deep breath, relax. Did that work? I hope it did. It's if you have 3 carbons and the N carbon is bonded to your main root or main chain, that's called N-propyl, and the N is small case. I'll learn later on why capital N means something else. If you have 3 carbons and the center carbon is bonded to the longest chain, that's called isopropyl. Anybody here ever hear of isopropyl alcohol? Give me a thumbs up if you have. Thank you. Well, that got its name from this group. And I'll teach you when we get into alcohols how it's got its name. Now, when you have 4 carbons, there's 3 possibilities, but the third one I've never seen used or in practice in real life. So I'm going to only teach you 2. You have 4 carbons and the N carbon of the alkyl group is bonded to the longest chain. That's called N-butyl, butane 4-butyl, N-butyl, this alkyl group. And if you have 4 carbons and 3 are bonded to the center carbon, and the center carbon is bonded to the longest chain, or you'll find out later this applies also to rings, it's called the tert-butyl. And in a couple of days, I'm starting out with the actual name, organic chemist, and I better warn you, we're lazy. There's an easy way out. We take it. We call this a T-butyl group. And now something personal. Dr. White loves T-butyl groups and isopropyl groups, the other ones too, but isopropyl and T-butyl groups have been good to me, and I've been good to them. So let's go back to our structure. We have found the longest chain and named it as heptane. We had an alkyl group, a substituent. It's methyl, CH3. Now, if you are writing a letter or sending a postcard to someone through the regular mail, not email, and you wrote their name down there, and this is their street name and the city and state and the zip code, what are the chances it will be delivered properly? Not good. You need to put the number. What's their apartment number or condo or house number? Whatever it is. And you need to put that down there too. Well, now we have an alkyl group, and you need to put down the alkyl group where that is. And we do that by determining a number. Just like a house has a street number, alkyl groups have numbers. And how do we do that? The main chain is numbered in such a way that the first substituent encountered along the main chain or the chain receives the lowest possible number. And each substituent is located by its name, like a methyl group, and the number of the carbon to which it's attached. And I'll go, probably may not get to it. If 2 or more identical groups are attached, then prefixes such as di for 2, tri for 3. I've never used tetra, but I put it down anyways, 4. And every substituent must be named and numbered. What does this mean? But before I show you, I should warn you. In organic chemistry, nomenclature is important. But nomenclature in organic chemistry is like going into a 4- or 5-star restaurant, very, very fancy restaurant, ordering 4 pieces of plain white toast and a glass of water. Boring, but it will keep you alive. But still, they're much better things. So this is not the most exciting part of organic chemistry, but it still is an important one. All right, let's find out how to find what carbon. Now, we only have one substituent, and you always, and this is a common mistake students make. Hint, this is a common mistake. They start from the carbon the alkyl group is on. No, you have to start from the end carbons, the number. In an alkane, the only place you start is from the end carbons. So if I start on this side, it's 1, carbon number 2, carbon number 3. The methyl group is on carbon 3. Now, if I start from the other side, 1, 2, 3, 4, 5. So there are 2 ways I can name that. It's on carbon 3 or 5. The IUPAC rule is you use the lowest number. Now you have to use that other high level math skill, which is lower, 3 or 5. Time's up, hopefully I'll pick 3. And therefore, this is called 3-methyl. Now, numbers are separated from letters by a hyphen. If you forget the hyphen, I won't tell if you won't, but please put it in. Makes my life easier, and it's the correct way. I will always use the correct IUPAC rules. So the IUPAC name for this molecule is 3-methyl heptane. How did we do that? We found the longest chain of carbons. Remember how I counted it? 7. Then we looked up on the table that you're going to memorize, hint, and that's heptane, 7 carbons. And now we have CH3 left over, and you've memorized, hint, the key alkyl group, CH3 on something. That's what this line means, is a methyl group. And so it's methyl heptane. The root name is always on the back. And then what carbon is the alkyl group on? 3. And that's how we did that. Let's do another one. One thing I should mention, there's a 20-second rule, and that is before you copy down what I write, give me 20 seconds to change my mind like I just did. I do these on the fly. All right, since time's running out, I'm going to do this quicker, but we'll come back to it tomorrow. Remember, we'll be meeting tomorrow on Zoom at 2, and you have the login. What's the longest chain? Well, if I go across 1, 2, 3, 4, 5, 6, another chain, 1, 2, remember carbons that are connected together by a line, 3, 4, and one more chain, 1, 2, 3, 4, 5. That's the rainbow color or whatever happened. But anyways, what's the longest chain? What's the largest number? Yeah, 4, 5, or 6. Hopefully I'll pick 6. Again, I'm speeding because we're almost done today. I don't like going over. I don't think that's fair to students. And when I'm face to face, if you ever had an instructor that keeps on going and going, the class ended, how come you're not done yet? I want to leave and get to my next class or do something. I don't do that. So the longest chain is 6. That's the root name. You've memorized this table. 6 carbons, hexane, 6 carbons, hexane. So the root name is hexane. And as soon as I say that, these carbons that I just circled are spoken for. Oh, look, we have something left over. And soon to be your good friend, CH3. And what's the name of that alkyl group? Well, you've memorized this chart. Please start learning this tonight. And CH3 bond to something is called a methyl group. Are we done? No. What carbon is the methyl group on? Well, you count from the ends of the carbon chain. If I start from the right going to the left, then it's on carbon 3. If I start from the left going to the right, it's on carbon 4, which is the smaller number, and time's up. Hopefully you all pick 3. So that's 3-methyl heptane. And if I look at the clock, oh my goodness, time flies when you're having fun with Dr. White in organic chemistry. Remember, I said since we're only taking 5 instead of 10-minute breaks, I'm going to end early. All right, quick thing about myself, and you'll find out I'm Jewish. And for those who don't know, my grandparents taught my parents and me Yiddish. That's a mixture of Hebrew and German. And one of the greatest women I've ever met in my life was my grandmother, Grandma Greenman. And whenever we'd leave, she'd say in Yiddish, "Gein gesund," which loosely translates means more than that, but go in health. And since the pandemic started, when I end every class, I will do this, and that is "Gein gesund," go in health. I also stole this from Beverly Hills Granny. Bye now, I'm done. I'll see you all tomorrow. Later tonight, I'll be posting this, and I'm done for today. Don't forget tonight at 6 to 7, if you want, stop by my office hour. And bye now. You can run away or walk away or whatever you want to do. Bye now. Gein gesund.